Lesson: Data cleaning and transformation using AI. Data cleaning and transformation are critical components of the data preprocessing stage in any AI-driven data analysis pipeline. With the increasing availability of vast amounts of data, the need to ensure that this data is accurate, consistent, and usable has become more important than ever. Leveraging AI for these tasks not only enhances efficiency, but also reduces the potential for human error. This lesson explores the practical tools, frameworks, and methodologies that professionals can directly implement to enhance their data preprocessing capabilities. At the heart of data cleaning is the need to address issues such as missing values, duplicates, and inconsistencies. AI-driven tools like Trifacta and DataRobot offer automated solutions to identify and rectify these issues. Trifacta, for instance, provides an intuitive interface that allows users to visually interact with their data, detecting anomalies through pattern recognition. This tool leverages machine learning algorithms to suggest transformations and corrections, thus streamlining the data cleaning process. Real-world applications of these tools demonstrate their efficacy. Consider a case study involving a healthcare provider that integrated DataRobot to handle patient records. The AI system identified and corrected data entry errors and standardized formats across disparate data sources, significantly improving the quality of the data used for patient care and operational decision-making. By implementing such AI-driven solutions, organizations can achieve more accurate datasets, leading to more reliable insights and outcomes. Data transformation, the process of converting data from one format or structure to another, is another area where AI can be employed effectively. This task often involves normalization, aggregation, and encoding of data to prepare it for analysis. Tools like TensorFlow and PyTorch, primarily known for their machine learning capabilities, also offer robust support for data transformation tasks. TensorFlow's Data API, for example, allows for the efficient manipulation of large datasets through parallel processing, which is essential for scaling data transformation operations. PyTorch, with its dynamic computation graph, provides flexibility in transforming data in real time, adapting to the specific needs of the data as it flows through the pipeline. This capability is particularly useful in scenarios where data is continuously generated and must be processed on the fly, such as in real-time analytics and IoT applications. By mastering these tools, professionals can ensure that their data is in the optimal format for downstream machine learning tasks, thereby enhancing the accuracy and performance of AI models. AI-driven data transformation also plays a crucial role in feature engineering, a process that involves creating new features based on raw data to improve model performance. Feature Tools, an open-source library, automates this process by using deep feature synthesis to create complex features from relational datasets. This tool allows data scientists to focus on high-level feature engineering strategies rather than getting bogged down in the minutiae of data preparation. An example of feature tools in action can be seen in the financial sector, where it was used to improve the predictive accuracy of a credit scoring model. By automatically generating features from transactional data, the model's accuracy was significantly enhanced, providing better risk assessments and reducing the incidence of bad loans. This case highlights the potential of AI-driven tools to not only streamline data transformation, but also to create more predictive power in AI applications. The implementation of AI in data cleaning and transformation is not without its challenges. One key issue is the need for high-quality training data to ensure that AI models can accurately identify and rectify data issues. This requirement underscores the importance of an iterative approach, where models are continuously refined and improved based on new data and user feedback. Moreover, it is essential to maintain transparency in the AI processes used for data cleaning and transformation to ensure that the results are interpretable and actionable. Incorporating AI into data preprocessing workflows requires an understanding of both the tools available and the specific needs of the data being processed. Professionals must be adept at selecting the appropriate technologies for their specific use cases, tailoring solutions to meet the unique challenges presented by their data. This involves not only technical proficiency, but also a strategic approach to data management, ensuring that AI tools are used to complement existing processes rather than replace them outright. One practical strategy is to start with a pilot project, integrating AI tools into a small part of the data preprocessing workflow to evaluate their impact and refine their deployment. This approach allows for the identification of potential pitfalls and the development of best practices that can be scaled across the organization. By gradually increasing the scope of AI integration, businesses can ensure a smooth transition and maximize the benefits of these advanced technologies. Furthermore, staying informed about the latest developments in AI and data preprocessing is crucial for maintaining a competitive edge. Engaging with the academic and professional communities through conferences, workshops, and online forums can provide valuable insights and foster collaborations that drive innovation. As AI continues to evolve, professionals must remain agile, adapting their skills and strategies to leverage new tools and methodologies that enhance their data processing capabilities. In conclusion, AI-driven data cleaning and transformation offer powerful solutions to the challenges of managing and preparing data for analysis. By leveraging tools such as Trifacta, DataRobot, TensorFlow, PyTorch, and feature tools, professionals can automate and streamline these processes, improving data quality and enhancing the predictive power of AI models. However, successful implementation requires a strategic approach, balancing technical proficiency with a deep understanding of the specific needs of the data. Through continuous learning and adaptation, professionals can harness the full potential of AI to transform their data preprocessing workflows and drive more informed decision-making.